Now, when we construct a project network with dummy activity, we should also be able to analyze the project network. All right? So today, what we're going to do is, actually, you need to be able to analyze a precedence table with a dummy activity in there, and be able to construct and actually analyze a project network with dummy activity from the precedence table. Now, before I actually start the lesson, I want to define a few things for you. A dummy activity or a task is sometimes needed to correctly represent the relationship of activities. A dummy activity or task is shown as a direct broken line. All right? It's important to show it as a broken line, as it does not actually exist. So make sure that if you see a network with a broken line, that means that activity or that task, it's actually a dummy activity. I will explain why it is needed. It is used to show the precedence where actual activities cannot show the precedence. All right? Now, remember a broken line, a direct broken line from a vertex to another vertex. The broken line is a dummy activity. All right. If you've got that down, let's have a look at this. What I've given you is a project network. Can you please attempt to complete this? I am not going to show you anything yet until you have completed this. 1, 2, 3, 4, 5, 6, 7. 7 activities there, 7 tasks. Try that and see if you can do it.
Sir, I like your shirt.
Thank you. All right. Try that and see if you can draw the project network.
Oh my god,
I mean, you should know that there will be a dummy activity in there. If you want a pen, don't use that one. That one's not a good one. That one has it. You know where the starting point is. Yes? Wait, that's good. You're getting there? I'll show you why we need the dummy activities. There will be some point that you'll be stuck. If you look at this network here, you can actually see that C, the immediate predecessor for C is A and B, whereas the immediate predecessor for D is only B. That will pose a little bit of a problem. Agree? You cannot label two lines with the same thing. That's correct. Thanks, Tom. Therefore, you need a dummy activity. All right, let me quickly show you. If you don't know the dummy activity, this will be what you will draw. Correct? However, I'm going to point out to you that this is not correct because D is not dependent on A. Yeah? D is not dependent, C is dependent on A. Alright? Let me highlight this. C is dependent on, alright? C is dependent on AB. So C is dependent on AB, which is fine. Whereas, if you look at D, D is only dependent on B. Alright? We've got an issue there. We really cannot say that C is dependent on A. This is telling me that C is dependent on A. And if you actually analyze this network, you will have problems. You will not find the correct minimum completion time. So, everyone focus for a minute, please. What I'm going to do is think about how I'm going to show in the network. How do I show D is actually only dependent on B only? Alright? We cannot have A and B going into this vertex and from there showing that A and B is the immediate predecessor of C and D. Alright? So what we can do is, I am actually going to split this into two. Alright? Highlighting this. This vertex will be split into two. Alright? Now, here, when I split into two, you can see that it's a better representation of what the precedence table show you. See, B is immediate predecessor of D. Because I split that, B. Now, you can see that B going through there, that is the immediate predecessor of C as well. Alright? But what you need to realize is the dummy activity does not have any duration. It's 0. You do not say anything. What you're trying to do is make an accurate representation of the precedence table. That's all. So the dummy activities here is telling me that, yes, B is the immediate predecessor of D. It is also an immediate predecessor of C. Alright? A is not. Alright? So the table indicate that A is not a predecessor of D. Here, you will have an issue. Alright? So you split that into two vertices and put in a dummy activity. In terms of analyzing it, it's still the same. Let me go through and draw it in your, sketch that in your book, please, and then I will go through analyzing it with you. Alright, once you've got it, let's go through analyzing it together. You must be able to analyze project network with dummy activity as well. So we know what we do when we analyze, we start off with 0, correct? Yeah? So, straight away we know, from here to here, we've got this and this. Two things is going in. Two things are going in. So you need to think about, let's go from here to here first, which is 3. Alright? So B3 has to finish. Now here, what happened? This is 0, but you still have to consider it as one of the activity. You must include that. So therefore, you know that over here, the earliest starting time for C will be 3. Because C has the immediate predecessors for C is A and B. Alright? So you need to think about that as well. There is 0 there. There's no duration, but you need to consider that when you analyze the network. Once you've done that, we can move straight on to this too, which is 3 and 6. That is 9. 3 and 4, that's 7. Alright. here 7 plus 3 is 10, 9 plus 5 is 14, so that's 14, oops, 14. And then there to there is 16. Alright, so let's move backwards, 16. 16 minus 2, that's 14. Now 14 minus 5 is 9. 14 minus 3 is 11. So that will be 9. 9 minus 6 will give me 3. Now 11 minus 4 will give me 7. 3 minus 0 will give me 3. So therefore you know the critical path is this. It includes a dummy, and that's it. Alright, make sure that you know what a dummy activity is. It does not have any duration. It's just used to indicate that B is an immediate predecessor for D, and immediate predecessor. Come in, Daniel, come in, that's fine. You can come here, come, just take a seat. Sure. Yeah. And B is an immediate predecessor of C. All right, it is not B. All right. So if you look at this network, AB is a immediate predecessor of C, but it's not D. So you got to think about how you could split that vertex into two vertices and put in a dummy task. Yep.
Why was the bottom circle on the left 3?
Because if you look at the latest starting time, we're going backwards again. 9 minus 6 is 3. Here's 3, correct? Okay. So going back to this point, 3 minus 0 will give you 3, correct? Whereas 11 minus 4 will give you 7. So you pick the, which number do you pick? So 3. So you must remember the dummy activity, the dummy task.
0.
That's 0, yep.
So, like, if we went back to the original
Mhm.
one where there was no dummy activity,
Yeah.
reword, you would be highlighting the B instead of A still?
Yes,
Okay.
but we can't really analyze this network because it's not the correct one.
Okay.
Because there's no dummy activity to show me that the predecessor for D is both A and B.
Okay.
You can't do that. All right? So you've got to be careful when you look at the precedence table. You must make sure that that will be, you have a dummy activity. So I've seen question asking you, what is the significance of the dotted line? Now, when you answer a question like that, the significance of the dotted line, you must relate it to the network. You must not say that it is dummy activity. All right? So for example, if you ask, why is there a dotted line there? So you have to explain in such a way that because B is an immediate predecessor, A is not an immediate predecessor to D, but it's an immediate predecessor to C, whereas B is an immediate predecessor to both C and D. So make sure that you explain in relation to the network. All right, that's really important. Always explain in relation to the network. Yeah? All right. I was actually going to use this to analyze the network, but I've already done it previously, so that's good. I'll give you my, do that as well. So, should have done it. All right, now this is example 2 from club exercise 70, question 6E. If you got your book, can you get it out please and try to analyze this and try to draw a network. Please do that. So you got to think about where you have to put in a dummy activity. Think about where you need to put in dummy activity. It's pretty obvious from here. So where you can see there's a dummy activity, you need to split it. Split the vertex into two vertices. It will take a while to get used to putting in a dummy activity or a dummy task. Yep. Yeah, sure. Now looking at this, look at where you've got two activities going into one activity. Alright? Look at that, look at the predecessor. So here you can see that with C, you've got AB coming in. Whereas with D, there's only B coming in. So that's already giving you an indication that you may need a dummy variable. Alright? Here, not dummy activity, not dummy variable. Whereas here, probably not, because you know that here, H is the last activities before you go to finish. And you can see that you might need, but from my just looking at this, I don't have any other predecessor except F here. So D, no, I probably don't need a dummy activity here, but that is a bit that you would need one.
Oh, that's why is the three?
That's connect together.
Yes. It doesn't.
E. E would go to N because there's no other. Alright. The other thing is E will go straight to the N because there's no other activities that require E to be completed before it finishes. So E will go straight to the finish line.
With no time.
Sorry?
With no time, just.
With time. So you combine these two together as one. You combine those two together as one. Alright? So that's the finish already. Yep, that's correct. Yep, that's right.
With this one here, did what? Did that also connect?
That would.
Or would they just connect to
Hang on,
that?
hang on, let's have a look. H3, H2.
So
Hang on, wrong one.
So these are all connected to the same one.
Should be. I'm a little bit confused. That's what it should look like. Yeah, okay, that's correct. That's correct, yeah. F, yep, E, yep, that's right, that goes H5. So you got yeah. You do need another dummy activity. Sorry, my fault. GH, you do need another. You do have two dummy activities. Yep. My fault. I wasn't reading the table carefully. You do need two dummy activities for this. This is probably one of the most difficult one. That's why I picked this as an example. Yes? One? You need another one. You need another dummy activity. Alright, my fault. There should be two dummy activities here. Here, this bit, and that bit. I did not read the table carefully. See, what happened is I forgotten that E, that's nothing after E. You can see that there's no, E is not a predecessor for anything. It should go straight to the end. Easy to make that sort of mistake, especially in the exam. We'll sort it out. All right. Let's have a look at how I did that. Okay, let's start. I know that A, B, both of them start at the same time. All right? And then C and D. C is dependent on A, B. D is only dependent on B. So you know from B, I need to split it into the vertex. I need to split into two vertices, one with a dummy activity. So that bit is here. Start off with AB, and then CD here. I know that one of them I'm going to split into a dummy activity. Here it should be obvious to me as well, D and F. D, I should split into a dummy. I should split the vertex and then include a dummy activity. So the next bit, pretty straightforward. Once you know you've done that, C and D will just be a straight line directly into a vertex. So C into one, D into the other one. All right? So what is after C? E and F. And you should know E is going to connect right to the end, but F is a predecessor for H. So you need to think about how you draw it. Look at this bit here. D is a predecessor for G. However, D and F, they are both immediate predecessors of H. So that is how you draw it. Three activities can go right to the end.
But how do you know whether it goes to some predecessor?
Okay, because you can
Assume?
sorry?
Just assume that it will go to H.
No, you don't have to assume, because you can see that in this predecessor table, is there E? That's none. So therefore E will go to the end.
Okay, that makes sense.
And look at G, is there any predecessor from G? No, goes straight to the end. H goes straight to the end. So that 3 will go straight to the end. That's how you analyze the table. Think about those tables and how you analyze it. Then of course, let's go back to analyze the network now, to find the earlier starting time and later starting time. Start off with O, 0, not O, 0, from the first vertex, and then keep going. And you'll know that the minimum finishing time is 17, could be 17 days or 17 hours, and you keep going back. And then of course you should be able to draw your, indicate your critical path. So when you write it properly, it's actually B, C, F, H. All right? The critical path will be B, C, F, H. Right? Critical path with the B, C, F, H. Again, take into account the dummy activity. You must highlight the dummy activity as a path as well. But when you actually write down your critical path, it's just B, C, F, and H. That's it. All right? So actually I'm going to stop here. There should be enough exercises in part for all of you to do. Next week we'll start on assignment problem and look at Hungarian algorithms.
So Mr. Lowe,
Yep.
can you just leave that up for a sec?
Oh yeah, sure.
If you're going from end of D, wouldn't that not be 7?
12.
The lowest? Oh no, you make it the highest, don't you?
Highest.
Yeah, okay.
That's the highest.
Yeah, no,
And then there's the lowest.
Yeah, okay.
17 minus. I've made a mistake. So 0 is 0. 17 minus 5. I made a mistake there.
Yeah.
I made a mistake somewhere. I definitely made a mistake somewhere coming back. All right? So, if you look at the way I've analyzed it, later starting time, I've got that as 12. 12 minus 0 should be 12. But 12 minus 5 is 12 minus 17 minus 5 is 12. So that should be 12. It's my fault.
That's crazy.
That's 12, not 5. Alright, that is 0. 12 minus 0 is 12. 17 minus 5, that should be 12. That should be 12. My fault. I've analyzed it incorrectly. As in when I do a backward scan. Alright, I'm going to stop here.